Okay, in this example, we're going to use the definition of f prime of x. Okay, the definition that we've talked about, namely this, the limit as h of x approaches 0 of f of x plus h minus f of x all over h. That's the definition of f prime of x. We're going to use that definition to find the gradient function of f of x equals x squared. Okay, so what does that mean? Let's think about this. We need to find the gradient function of f of x equals x squared. They're just saying find f prime of x. Okay, they're just saying what is this equal to? All right, and we're going to use this definition. It's also called first principles. Okay, so if we are differentiating by using first principles in this example, all right, so we start with f of x equals x squared. All right, and we also have to find f of x plus h. Because if we want to use this definition, we're basically going to find the limit of this difference quotient. This is called the difference quotient. We're going to find the limit of this. So we have to find f of x, which we're already given, okay? And we're also going to have to find f of x plus h. So notice that the input here will change on f of x. So f of x is x squared. F of x plus h, I'm just changing the input so it changes all of my x values. Okay, so the x value in this expression becomes x plus h squared. And I just go ahead and plug that into my definition formula. Okay? And so from there it's just regular limits math. Okay? So we take the top part here, expand it all out, and we get x squared plus 2xh plus h squared. And then these, notice that this minus x squared here and this x squared will cancel. So we're left with just this part in here. So we have 2xh plus h squared all over h. I can't plug in my h. To solve this limit, I can't plug in my h yet because I'll have an undefined expression, so I factor out the h's from the top. And that h cancels out with the bottom, and then I'm left with a 2x plus h, and then I can substitute. Okay, so notice that the gradient function here, once I substitute 0 in for h, I get 2x. So the derivative function that I get is 2x. All right, let's think about what that means. The derivative function, this is the function that gives me the slope of the tangent line. Okay, to f of x at any value of x. So here I have if I have x squared, okay, the function 2x will tell me the slope at any x value here. So if I said, find the slope at the point 1, okay, the slope of the tangent line then would be this line, right? And so if I plug in 1 into here, I'll get 2, and that would be the slope of this line. The slope of this line would be 2. Okay? If I had 2 in here, I would put 2 into here. I would get basically be finding f prime of 2. This would be f prime of 1. Okay? If I wanted to find the slope at this line, at this point, I would be looking for the slope of this line. And the slope of this line would be 4 because f prime of 2 is 4. Okay, if I put 2 in here, I get 4. So that's the usefulness of this derivative function. It's a function that tells me the slope of a tangent line at any point on my original graph. Okay? All right, let's take a look at some notation here. We're going to introduce a different type of notation. So far we've seen that if I have f of x, the derivative is f prime of x, okay, prime of x, okay, f prime of x. Oops. Okay, well now sometimes we're given the expression in terms of y, so sometimes I'll have something like y equals 2x squared, and then I have to find the derivative of this. Okay, well when I'm given it in terms of y, I usually write y prime as my derivative, or I write dy dx as my derivative. Okay? So Just be aware of that. It all means the same thing. F prime of x is the same as y prime is the same as dy dx. Okay, so that's kind of a summary of the different notations that you'll be seeing when we talk about derivatives. Dy dx here is not a fraction, so please don't try to solve for dy or think of d as a variable or think of this as a division sign, okay? This is simply a symbol that means a derivative, okay? Just think of it as a symbol that means derivative. Okay, and just to kind of recap here, we already talked about this in the previous example. If I know f prime of x, then f prime of 2 means what? And f prime of negative 1 means what? F prime of 2 and f prime of negative 1 are the slopes or the derivatives at the values of x equals 2 and x equals negative 1. Okay? The slopes of the tangent lines at those points. All right? Basically what I explained up here.